Hi friends, welcome to the new lecture of our series on data mining and data warehousing. Today we are going to discuss advanced classification techniques such as our Bayesian belief network, backpropagation algorithm by neural network, and SVM, which is basically support vector machine. So let's start this lecture now. Bayesian belief networks. As you know, Bayesian belief network are basically probabilistic network and are also known as Bayesian network allows class conditional independence between subset of variables. So what it does is it allows the independence and conditional and take into consideration the probabilities involved with the variables while building the network. And what it does it is basically a directed acyclic graphical model of causal relationship where we represent dependency among the variables, and usually what we do is we provide a specification of joint probability distribution. Okay, so what we specify here are our nodes, which are basically random variables, and links, which are basically dependency, and we can represent like a parent child relationship here. And there can be some variables which do not have dependency, and we do not, it being a cyclic graph, we do not have loops or cycles. So look at an example of Bayesian belief network where you can find the characteristics like family history, smoker, emphysema, dyspnea, positive x-ray, and lung cancer. So what we are doing is we are trying to identify our variable lung cancer. So what we do, we try to write down the probability with respect to lung cancer. So what are the variables which are affecting lung cancer? It is basically our family history and smoker. So what we plotted, basically plotted a conditional probability table for variable lung cancer. So either the lung cancer could be yes or no, and based on that we mapped like family history for smoker, family history for non-smoker, non-family history for smoker, and non-family history for non-smoker. So these are the four possible combinations which we could have got from our two attributes. uh, so this is the combination which we got, fine. And this is suppose data is being provided by our data set. So now what the conditional probability table does is it represents the conditional probability for each possible combination of its parent, and derivation of probability of a particular combination of values of a particular tuple from CPT just follows our that belief, like probability of x1 to xn, that basically the tuple is equal to the product of the 1 to in probability of xi if parents is yi. So all these multiplied together gives us the probability of the particular tuple. Now we'll talk about classification by backpropagation, which is basically all based on neural network. So backpropagation is basically what is, it is a neural network learning algorithm which helps in reducing the error and building the model. And neural network basically was started by psychologists and neurobiologists to develop and test computational analogies of neurons. And if we talk about neural network is a set of connected input output units where each connection has a weight associated with it. As you know, the neural network have multiple layers of input, and this and the input of this of a layer is generated by the output of the previous layer. So this is basically in that case a feed forward network. And basically what there are some weights assigned to each edge. So what happens is during the learning phase, the network learns by adjusting weights so as to able to predict the correct class labels on the input table. What actually we expect from the network is when we apply a certain input, it should provide a correct output. And for providing the correct output, what we require is we require the adjustment of weight, which is what done by the neural network. And it is also referred to as connectionist learning due to the connections between the unit. Now we'll talk about backpropagation in detail. It is basically an iterative process and where a set of training tuples, and compare the network prediction with the actual known target value. So suppose the value is coming out of the network is 10 and the target value should be 100. So what we do, we try to adjust the weight in such a manner that the 10 should convert into 100 based on the same computations. So for each training tuple, the weight are modified to minimize the mean squared error between the network's prediction and the actual target value, and the modifications being made in the backward direction from the output layer through each hidden layer down to the first layer. We call it backpropagation. Since it is propagating from the output to the input step by step at each layer, it is known as backpropagation. And the steps followed are: first we initialize weights to a random number which is usually small in nature and associated it with the biases. Then what we do is we propagate the input forward by applying the activation function so the output is generated. Then what we do, we backpropagate the error by updating the weights and the biases. And where we terminate where we get a relatively very small error, or we may apply the condition like the 5% error we can grant. So the condition basically depends on what we are expecting from the network. Now we are going to talk about how neural network act as a classifier and what are the weaknesses and strengths are involved in this when we work neural network as a classifier. So as you learned that the neural network is able to predict the class labels. So what are the advantages and disadvantages regarding that? So first we'll talk about the weaknesses or the disadvantages. First is it takes long training time for a neural network to train. Secondly, it requires a number of parameters typically best determined empirically. So basically the network topology or structure. When it is proper, it will give the result, otherwise it will be able to not provide us suitable results. Then poor interpretability, which is because it is difficult to predict the symbolic meaning behind the learned weight and of hidden units in the network. We are not able to identify why the particular edge is weighted less or some edges are weighted high. So interpretation of the neural network is a key concern and we are unable to do that. So it basically forms a weakness. Now we are going to talk about the advantages or the strength of neural network as a classifier. Firstly, it is very tolerant to noisy data and it is able to classify untrained patterns. So noisy data and untrained pattern are the advantages in case of neural network as a classifier, and it is well suited for continuous valued input and output. So there is no need to form classes or groups for continuous values in neural network as well. Furthermore, successful on an array of real world data, handwritten letters, so it offers real-time ability, and the algorithms are inherently parallel, so this can speed up the process. And furthermore, the technique that have recently been developed from the extraction of rules from trained neural networks have imparted the power of neural network to provide more and more accurate results with less time, basically the less computation time. Now we are going to talk about support vector machine. Support vector machine is a relatively new classification method for both linear and non-linear data, but what it usually uh, gives is it is more suitable for a non-linear mapping to transform the original training data into a higher dimension, and with the new dimension it searches for a linear optimal separating higher plane or hyperplane or the decision boundary. So what hyperplane decides it basically classifies the data into two categories, and on the one side of the hyperplane there is one classific class, and on the other side the object which lies belongs to the other class. So with an appropriate nonlinear mapping to a sufficient high dimension, data from two classes can be separated via a hyperplane. So hyperplane is basically the plane separating the two classes. When we move the data to a higher dimension, fine, this is the idea of support vector machine, and support vector machine finds this hyperplane using support vectors, basically the essential training tuples and margins defined by the support vectors. If we compare SVM with neural network, SVM basically relies on deterministic algorithm, whereas neural network relies on non-deterministic algorithm. And there is nice generalization properties in support vector machine. But while talking about neural network, there is generalizes well, but doesn't have strong properties or mathematical foundations. Then we talk about SVM. They are basically hard to learn in batch mode using quadratic programming techniques, but neural network can be learned easily in incremental fashion. And what SVM does is it uses kernel which can learn very complex functions, and neural network basically relies on multi-layer perceptron for complex functions. We have discussed our SVM, neural network, and Bayesian belief network. Kindly go through these topics again from your textbook. And in case of queries, kindly mail me at utsav@gwdca.ac.in. Till then, take care of yourself and keep studying. Thank you.